Hello students, from today onwards we are going to start our new unit. Okay, so we have already covered three important aspects by reading about them in three different units. Okay, now after we have finished the multi-agent interaction concepts, it is very important for us to understand that how learning is formalized as well as how with the use of different algorithms they can be utilized and implemented in the case of your multi-agent systems. Okay, so the new unit, let me write it for you. So we are going to start our unit 4 and its name is learning in multi-agent systems. So there are two key aspects of this unit. Okay, first in wherein we will talk about the learning mechanisms. Okay, and therein we will discuss about simple concepts like what is machine learning. Okay, and the machine learning problem, what is that? Then we will talk about a very simple concept and very at the same time very important concept called cooperative learning. Fine. And we have already discussed when we were talking about the games in normal form and games in extended form that there is a concept of repeated games. Okay, so we will discuss the repeated games at length over here. Fine. So we will discuss that. And then finally, we will talk about collective intelligence. Okay. And the second part of our this unit is where we discuss the concepts of cooperation, then coordination, and collaboration. Now it seems like all the three terms are. It seems like all these three terms are same, but they are not same. We'll see how they differ. Okay, and then in this we will talk about the concept of voting, auction, and negotiation. So I gave you a hint at while we were discussing about the different types of games and distributed constraints that whenever we want the multi-agents to interact, therein the interaction can be done with the use of some algorithms, but there are certain limitations wherein the concept of negotiation, auction, and voting comes, where they interact in with the use of they use certain algorithms to form such kind of interaction. Okay, so this is one thing. So let's talk about learning in multi-agent systems first. Okay, we will talk about this. We will start our discussion of this unit by discussing what basically is learning in multi-agent systems. You see, whenever we talk about learning in case of multi-agent systems, so there are two types of learning. Okay, so two types of environments wherein the learning happens. So let's see what are those environments. So there are two kinds of environments, learning environments. What are those? So first environment is the cooperative learning environment. Okay, so first learning environment is cooperative learning environment. And what is the second learning environment? Second is repeated games with learning agents, wherein we talk about the games played by the agents, but they learn from that particular game. Okay, so we will discuss at length, but just to make you remember um, that when we were discussing about the repeated games, therein we talked about the playing of same game more number of times, and then based on certain probability, we were discussing which action or strategy can be chosen. So therein we talk with this that comes as part of your repeated games with uh, learning agents. Okay, now you see, whenever we talk about or whenever we say that cooperative learning, we must understand that since there are many multi-agent systems, okay, and what is the goal? The goal is to explore or monitor a particular space, है ना? So when we say that there is a goal of exploration or monitoring of a particular field or given space or a particular area. So what happens? So in that particular multi-agent system, there are a lot of agents. So what each single agent will do, they have local view of their own areas, correct? So when I say that they have local view of their own areas, it means that let us take this an example to understand the local view. So, for instance, there are three or four sensors which are acting as an agents who are monitoring that particular area. है ना? So, what is the purpose of that agent? Let us suppose those sensors are trying to acquire the value of temperature in their region. Now, it's not like it's sensor that is located in Jaipur city will sense the temperature of let us suppose Delhi. Okay, so why it? Because there is some communication range or sensing range of that particular sensor. Fine. So the sensing range. So for instance, it may happen na, like this is one sensor. So this is the range of that particular sensor. Maybe it may be outlined by the radius. Okay, so in geometrical form, definitely I'm saying. So what is this? This is the sensing range, है ना? So this sensing range means this is the sensing range of this particular sensor S, है ना? But this area, what you see over here, it may be said as the local view or local area of that particular sensor. So currently, if we talk about sensor S, so this sensor is having the information about its local area only, correct? So beyond this, it is not, it cannot be found ki what is the temperature of that particular area because of the sensing range, है ना? So we can define the local view based on sensing range if we are talking about sensors. So based on different types of agents, their local views can be defined. So so each agent, what they are responsible for, they are responsible for having their local view, है ना? Now may be possible that each agent learns a map of its world, है ना? Now if a particular sensor S is there and its area is there, this is the local view, so it knows its map, correct? And what may happen that similarly there are other sensors like S2, S3, S4, they all have their maps ready with them. Okay, so they have their own maps. So what they will do, they will share these maps with each other. What is the purpose of this? Because all the sensors S1, S2, S3, S4, each of them have their local view in terms of some map, and now they are sharing their views so that they can understand what is the global view of this particular area. है ना? So outside of their local range, it will be the global view of that particular sensor. So S2's global view will be out of its sensing range, है ना? So out of its local view, that will be called as the global view. And global view is also important, है ना? ऐसा नहीं होता है कि if you are a person who is living in India, you don't want to know about the happenings or incidents that are happening out that are occurring outside India, है ना? In some other foreign countries. Similar and vice versa also. They also want to know about India. So since you are living in India, you have access to some of the news channels or television channels which gave you the information about India only. But there are certain ways, either with the use of some online platforms or some other channels with which you can know what is happening around the world as well. Correct. So similarly, they are also doing the same for us, you know? And the governments also do some kind of policies, and they create some kind of policies so that the cultural exchange is possible. So what I'm trying to tell you is that there are two important things. One is the local view, and second view is the global view. And herein, to map local view to global view, cooperative learning is required. So how they are cooperating? So they are having their own local views. They are sharing their maps or local views with their neighbors. So what they are doing, they are aggregating their corresponding local views, and then they are forming a global view. And what are how it is getting done cooperatively. Fine. So this is what the concept of cooperative learning. And then secondly, when we talk about this concept, that is the repeated games. So what happened in repeated games with learning agents? So definitely there are two things. Now, one is there are two important uh, terminologies. One is that you have different learning agents with you, and second is you have those learning agents are playing some games repeatedly. Okay. Now you see, we can understand by a scenario wherein a competitive environment is there. Okay, so let us suppose that there is a scenario, so it is a competitive environment scenario, है ना? So what happens in competitive environment whenever? So we have been discussing a lot since our unit one, since the start of this course, that whenever we say competitive environment for the agents, means agents are trying to maximize their utility. Okay, and they so it's not like always they will try to maximize their utility and they will be successful in that particular approach, but they can try to maximize their utility by being selfish about their utility, about themselves, and rational about themselves. And then in doing so, if they fail, then they can learn from there. And the learning can be in terms of two important parameters. One is the learning can be in terms of two parameters. One could be the behavior, that is very important, and second is the weakness. Okay. Now, what do you mean by behavior? So, which behavior was utilized to increase the or maximize the utility? Okay, and if they were that particular agent was successful, fine. If it was not successful, then what was the weakness because of which it could not get successful? Okay, so these two are very important parameters of your learning, है ना? So what happens in such kind of competitive environments? Every time, whenever we talk about a competitive environment, now you see again here some parameters are there. So whenever we say there is a competitive environment, herein first the dynamics of system changes. Fine, means your real time scenario, है ना? It's not always said that if you have set an agent to behave in certain way, then always they have to do so. Then where is the learning? Because the real time scenario or the real world always changes its dynamics. Changing the dynamics means some at some point of time some inputs are required, and giving a certain output based on that particular input and processing may be possible that after some time if the same input you are giving, then processing differs based on the changes in the environment. Fine. So what happens? One is that dynamics, it always changes. And also, second important part is that the stable equilibrium must be reached. So we have discussed equilibrium ना, कोई भी एक सिस्टम होता है तो वहां पे equilibrium का मतलब क्या होता है कि that is a stable strategy, है ना? That is the strategy that is most favorably used, that can be used favorably. Fine. So you can favor that particular strategy because it will always result in a particular means in maximization of utility or giving you a payoff that is better than the previous attempt. Okay, so here in what happens, like you want the learning to be in such a way that it maps the dynamics of system that is always changing, and then second, in such a way that the agents must determine ki which is the equilibrium, and it should stabilize that particular stabilize, it should get itself stabilized to that particular equilibrium. Fine, and that equilibrium should also be stabilized. It's not like one time you are getting one strategy, and for the same input and output and processing you are getting different types of strategies. So that's why equilibrium is very important, है ना? So we will see this. This all comes as part of repeated games, है ना? Whenever we discuss the repeated games, so why the games are getting repeated? If you remember the prisoner's dilemma and iterated prisoner's dilemma. So in case of prisoner's dilemma, the Nash equilibrium was different, है ना? But your Pareto's optimal principle was entirely different, है ना? The results. Then social welfare was all different. You might have seen that in your payoff metrics, 3-3 was if you are getting 3-3 if both the prisoners are cooperating, but they both are defecting and getting 1-1 points as the utility. Okay, so what is happening over here? Basically they are trying to, so in iterated prisoner's dilemma, they tried to play the same game multiple number of times, and in doing so, they tried to um, they tried to settle down on a particular strategy based on some probabilistic condition. We will see in detail about it. Okay, now let's talk about our first topic, that is your machine learning problem. Okay, let's talk about machine learning problem. Now, you see, whenever we talk about machine learning problem, first thing that must come to our mind is what is the goal of machine learning problem. Okay, so let us see one by one. Okay, so what is the goal? So to develop an algorithm, fine. So there is a need to develop an algorithm that increases the ability of agents to match a set of inputs to match a set of inputs to their corresponding outputs, to their corresponding outputs. So this is the goal of the machine learning problem. Okay, why we go for machine learning problem? And definitely, if the question comes to you, and you are a Navy user, and I ask you that tell me why machine learning is important. So you may always say that there are two terminologies associated with machine learning. One is machine, second is learning. So since learning is involved with the machines, so definitely we are trying the machines to learn given a certain condition. Okay, or if the dynamics of the environment changes. So based on that, it has to do something. Fine. Now there are some key aspects of this particular goal. What are those key things? So definitely first one is the development of algorithm. This must be underlined. Okay, so in machine learning problem or machine learning as a whole, as a field, what you do, you develop some algorithms. Okay, why? So second underlying thing is you are trying to increase, what you are trying to increase, you have a set ability of agent, but you want to increase the ability of that particular agent. Okay, and why you want that particular agent to increase its ability? To match what? To match, भाई different set of inputs हैं, उनको corresponding outputs के साथ match करना है. Okay, so same thing आ गया ना जो मैंने आपको पहले भी बताया. What did I say कि if the dynamics of the system changes or dynamics of the environment changes or real world scenario changes, so it's not like कि your algorithm should be for a particular environment only. Your algorithm should be developed in such a way that it tries to increase the ability of a particular agent. Why that ability is required? Because always if a given set of input is given, we want a certain output to be received from that particular machine. ठीक है, सिंपल सा बात है ना. अगर आप डेस्कटॉप यूज करो, लैपटॉप यूज करो, ओके, एंड अदर हैंडहेल्ड डिवाइसेस यूज करो, if you are trying to print a paper, so आप इनपुट क्या दोगे? एक पर्टिकुलर फाइल जिसकी प्रिंटिंग चाहिए, एंड आउटपुट आपको क्या चाहिए? आपको एक उस फाइल का आउटपुट चाहिए इन अ पेपर फॉर्म, है ना. तो उसका जो कमांड है वो ऑलवेज विल बी गिवन टू दैट पर्टिकुलर प्रिंटर. सो अब आप चाहे कोई भी डिवाइस यूज करो, अब चाहे किसी भी नेटवर्क में यूज करो, ये वर्क है तो इट दिस मस्ट बी डन. अब ऐसा हो सकता है कि इफ द सिनेरियो चेंजेस, ओके, इफ द नेटवर्क चेंजेस, so your printer is not getting the output, है ना, or your printer could not get the input from that particular handheld device or some other devices from which you are trying to give the input command. ठीक है, तो इसके केस में क्या है कि भाई तुम अपने सॉफ्टवेयर को इस तरीके से बनाओगे दैट some algorithm ऐसे डिजाइन करोगे अपने सॉफ्टवेयर में कि दैट it increases the ability of that particular handheld device, so that कि भाई different scenarios में वो अपना जो errors होते हैं, so they can try to be so reliable that they can self uh, uh, means they can try to improve from themselves, so as to nullify that error or reduce the impact of that error and still give the print, है ना. So that is what the goal of machine learning. Now when we say that uh, so when we say that machine learning's goal we have obtained, now we must understand the formal definition also. Okay, what is the formal definition of machine learning? So let's see that. What is the formal definition of machine learning? Okay, so machine learning's formal definition says that, let us suppose we have a large set of examples. Okay, so E is a large set of examples. Fine. So we have assumed that, है ना, कि there is an existence of a large set of examples, है ना. So there is an example E. So for E that belongs to capital E, small e that belongs to capital E means there is an instance of an example. Okay, from a set of examples, capital E. So what is a E? So is a pair wherein E can be defined in terms of two variables, A and B. Now, what is A and what is B? Where this A belongs to capital A, small a belongs to capital A, and it is the input the agent receives. Fine. And B belongs to capital B. What is that? So it is the output the agent should produce. Okay, so the output the agent should produce given A. Okay, so given a particular input, what is the expected output that is getting produced? So that will be denoted by B. And when we make it a pair A comma B, that is defined by the variable E, where E is an instance of a large set of examples, capital E. Fine. So so what basically we are trying to do, so let's understand it with our third step of defining the formal definition, so of defining the machine learning problem formally. So agent is supposed to find a function. Agent must find a function. Fine. That function can be represented by f, that is a function from A to B. Okay, so this agent must try to find, and this is what the we can formally define with the for the machine learning problem we can define it. Okay, so let's take an example है ना. So a, let us suppose your a, what is a? A is the set of inputs. ठीक है, तो as set of inputs you are giving, let us suppose, set of photos. Okay, you are providing the set of photos, and you have b, that is the set male or female. Now what is the function when I say A to B? So mapping of photos in such a way that those photos are of males or females. Fine. So this is what we can say for a particular for this particular example. है ना? So herein E tells the program. If you say that you have an element small e, so it will tell the program कि भाई what is E basically? So it is a mapping from A to B. What is A and B? So A में क्या होगा? A particular photo is there, है ना? So this photo is for male or female. So E is the mapping, and this mapping can be defined with the use of this function f, that is from A to B. Fine. So this is how you can formally define your machine learning problem. Fine. Now, next important thing that we must understand is, if you have a machine learning problem, let us say that we have a machine learning problem. So it can be understood, okay, by two important terms. One is control test. Controlled test. And what is the second one? Testing set. Fine. So when we say that we have a control test, so therein you have set a large set of examples, capital E, na? So you will divide your capital E into training set first, okay, and then you train the agent. Fine. And when you use a testing set, so therein it is this testing set you will use to test the performance of the agent. So this is related to the testing of performance of agent. And when you say the control test, so therein two aspects are there. First, divide the training set. You are dividing the large set of examples, and then each training set you are trying to train the agent. You train the agent. Fine. So machine learning problem can be understood in these two ways. One is control test, second is testing set. So in control set, what you do, you divide the training set. Why division is important? Very good question should come from you. That why this division is important. You see, if you have a large set of examples, capital E, okay. So what E holds a large set. So large set 100 होगा कोई problem नहीं, 200 होगा कोई problem नहीं. मान लो कि करोड़ों का set है, or even लाखों का set है, let us suppose, okay, a lakh number of elements are there. Now what will be the problem in there? So the processing, okay, processing power should be increased, है ना. तो अभी हम क्या करते हैं कि भाई सिंपल सी बात है ना कि अब इतना प्रोसेसिंग अगर एक साथ नहीं कर सकते हैं, so let's divide, and each training, with the use of each training set we will just train the agent, है ना, and then finally we can see the performance by combining that, है ना. Now what happens, what I told you कि first you divide the training set, train the agent, and then definitely when you are training the agent, भाई you have testing set also, है ना, क्योंकि आपने जो divide किया है training set को, you can use that as your testing set. और फिर आप देख सकते हो कि however you have trained, is the agent working as per the, is the agent giving you performance as per the training, okay. But in some scenarios it may be possible that first you train the agent and then test it, okay. So in it becomes very impossible. भाई कभी कभी ऐसा होता है, every time you want कि भाई पहले train करेंगे तब test करेंगे, okay. but sometimes it becomes we will see in coming lectures ki where is it possible. So what happens like कि sometimes फर्स्ट ट्रेनिंग देके टेस्ट करना डिफिकल्ट होता है. क्या होता है, पहले हम कुछ कुछ ऐसे रियल टाइम सिनेरियोज आ जाते हैं जहां पे उसकी टेस्टिंग हो जाती है पहले, ओके, एंड परफॉर्मेंस नहीं कर पाता है, तो हमें ये पता चलता है कि ओके ही इज नॉट गिविंग बेस्ट अ गुड परफॉर्मेंस विद रिस्पेक्ट टू दिस पर्टिकुलर सिनेरियो, सो लेट्स ट्रेन इट फॉर दैट पर्टिकुलर सिनेरियो. सो व्हाट हैपेंस ओवर हियर, तो यहाँ पे क्या होता है कि जब पहले ट्रेन किया और उसके बाद टेस्ट किया फॉर परफॉर्मेंस इट्स फाइन, बट वेयर इन द टेस्टिंग हैज हैपेंड बिफोर द ट्रेनिंग, सो वहां पे क्या होता है कि जो आपका ट्रेनिंग और टेस्टिंग एग्जांपल्स होते हैं ना, उनके बीच में थोड़ा सा गैप आ जाता है, एंड देन दैट वी ट्राई टू मिनिमाइज, है ना, ये जो गैप है मिनिमाइज करना होता है. भाई आप मिनिमाइज कर रहे हो ना, आपको ज्यादा से ज्यादा सिनेरियोज के बारे में सोचना है, एंड दो सिनेरियोज शुड बी फेड इनटू योर मशीन एंड देन ट्रेन्ड एंड देन दे आर गोइंग टू परफॉर्म ऑन दो सिनेरियोज, है ना, सो दैट देयर टेस्टिंग कैन बी डन. बट अगर आपने कोई सिनेरियो छोड़ दिया तो डेफिनेटली इट विल हैपन ना, लाइक while the system is performing or your multi-agent system is working in that particular scenario, some scenario you have leave, you have not given the training, and when that scenario comes, either it is showing you the error or it is saying that this particular scenario is not understood by me. Okay, so वहां पे क्या होता है कि भाई वहां पे एक गैप आ जाता है, वो गैप मिनिमाइज करना है हमें, ज्यादा से ज्यादा कोशिश करना है कि maximum times we have to think of all the scenarios, all the possible scenarios, and then we have to assess the quality of our training and then give the training, and then finally we have to assess the performance. Okay, now I told you the formal definition, correct, and then told you about the control set, testing set. Now if we want to find the um, try to find and understand what is going on in machine learning problem in terms of graphical representation. Okay, so let's see कि in terms of graphical representation how we can understand it. So मैंने आपको क्या बताया है कि whenever you define a machine learning problem in a formal manner, so therein there is a function that is trying to map your set of inputs to the possible set of outputs given the set of inputs, है ना. So F2A यही कर रहे थे हम लोग, ठीक है. So what is happening over here, you are trying to find a function. अब हम लोग क्या करते हैं, एक ग्राफिकल रिप्रेजेंटेशन देखते हैं, ठीक है. So let's say that we have a 2D graph. Okay, so your y-axis says or expresses the speed, है ना, and x-axis give you the weights. X-axis give you the weights. Fine. Now some distributions are there based on the values. Okay. Some distributions are there. What are these distributions? The values are in terms of plus and minus. Okay. I'm not saying ki plus and minus what it represents. I am saying that based on your speed and weights, some values are represented in 2D graph that you are seeing over here. Okay. Now भाई सिंपल सी बात है, अब आपका यहाँ पे गोल क्या है पहले ये समझ लेते हैं. गोल इज टू हैव टू ट्राई टू सेग्रीगेट ऑल द माइनस वैल्यूज फ्रॉम प्लस वैल्यूज. ठीक है, हमें क्या करना है, केवल फाइंड आउट करनी है हाउ मेनी माइनस वैल्यूज आर देयर. ओके, सो मे बी पॉसिबल, सो लेट मी राइट दिस पर्टिकुलर गोल. सो व्हाट इज दिस गोल? द गोल इज कि फाइंड number of minus values, okay, from the graph. So this is your goal. I can also rewrite this particular goal in such a way कि भाई cluster all the minuses, ठीक है, all the minus values. I can also write this particular statement as the goal. ठीक है, तो भाई ये गोल है तो अब इसके डिफरेंट वेज हो सकते हैं ना. अब आपने फर्स्ट टाइम अगर कोई मशीन लर्निंग प्रॉब्लम लगाया है तो ऐसा हो सकता है कि लेट अस सपोज ये ऐसे कोई फंक्शन है that segregates it like this. Let us suppose this is your function f1. Okay, maybe possible some other function is there that tries to segregate this in this way. Fine, so this could be your function f2. Okay, and some other function is there that is trying to segregate all your minus values like this. So this is your function f3, है ना? ऐसे कितने functions हो सकते हैं? हो सकता है कि कोई एक particular set है जो किसी एक माइनस को छोड़ भी देता है, कोई एक क्लस्टरिंग हो रही है जिसमें दो माइनस वैल्यूज छूट जा रहे हैं, ठीक है? तो जो जो जिस जिस फंक्शन में कुछ वैल्यूज छूट गए हैं, so those functions are not correctly mapping your a to b, okay, not correctly clustering your minus values, है ना? But the three different functions that I told you, you see, with different, they are three different functions. What does it mean? So this means that f1, f2 and f3, they are three different algorithms. Fine. So three different algorithms are used to cluster the minus values. Okay. So f1, f2, f3, they are doing the same, but they are doing it differently. So what we are trying to find, say over here, is that, you see, machine learning performs the concept of induction. Okay, so what we are trying to find out is, when we use machine learning, so in case of machine learning, the induction process is utilized. Okay, now if you remember, induction में क्या होता था, डिडक्शन वर्सेस इंडक्शन जब हमने पढ़ा था, तो डिडक्शन में क्या होता था, हमारे पास थियरी था, थियरी से हम नीचे जा रहे थे और हम अपने ऑब्जर्वेशंस निकाल रहे थे। इंडक्शन में क्या होता है, ऑब्जर्वेशंस होता है, उसके बेसिस पे हम कुछ थियरी पे आते हैं, करेक्ट? सो इफ यू रिमेंबर आई टोल्ड यू अबाउट एरिस्टोटल, दैट एरिस्टोटल वाज इनटू डिडक्टिव रीजनिंग, एंड इंडक्टिव रीजनिंग में शर्लॉक होता है जो अपने ऑब्जर्वेशंस के बेसिस पे थीसिस पे जाता है एंड फाइंड्स आउट द थियरी। ओके, सो यहाँ पे मशीन लर्निंग प्रॉब्लम क्या होता है, दे ऑलवेज थिंक अबाउट इंडक्शन एंड दे डू द इंडक्शन over some set of examples, है ना? What are these examples? So the set of problems that are given है, examples क्या है, कैपिटल ई जो हमने बताया, ठीक है? So उसमें क्या होता है कि वो इंडक्शन करता है, एंड इंडक्शन के बाद क्या, what they try to do, they try to categorize, okay? And जो categorization होता है, उससे basically what we are trying to find, so we are trying to find कि the categorization is correct with respect to goal or not, this question we try to address. Okay, so here you can see now in this particular example what is happening, f1 categorizes minus, okay, f2 also does it, f3 also does it, but different algorithms are used, they categorize in different way. Now the optimized function is a different thing, we are not trying to find the optimized function, that is a different topic that must be addressed whenever you will study machine learning problem or machine learning as a course, that there you will understand that optimization always comes as part of your machine learning, ठीक है? So machine learning में आप क्या करोगे optimization में, भाई हमने f1 f2 f3 तो हमने पता कर लिया, but which clustering is better, which function is performing better, ठीक है? तो वहां पे फिर वो better performance के लिए आप optimization के different principles का use करते हैं, that is a different thing. But what I am trying to focus here is that since your machine is given a chance to learn, so you cannot say that initially during, see, भाई किसी बच्चे को अगर आपको चलना सिखाना है तो आप अगर बोलोगे ऐसे ही खड़े हो, ऐसे ही चलो, ऐसे ही बोलना है, ऐसे ही बात करना है, so that particular person will not understand कि there are some other ways also. So similar, in the similar way, you just make an analogy. So if you are trying to give learning to the machines, so machines should also be given the task कि भाई goal is this, try to find the solutions or try to find the different algorithms with which we can categorize or cluster the minus values. So what your function, what your agent has done, so that your machine or your agent has implemented three different algorithms based on his past learning or past experiences, and now three different algorithms. So what you got, कि भाई agents और what agent has experienced कि 3 different algorithms can be applied. फाइन. सो इसके बाद जो करना है वो तो फिर वो एडवांस्ड थिंग है, दैट वी आर नॉट गोइंग टू डिस्कस. बट यू मस्ट अंडरस्टैंड दिस कि भाई जब लर्निंग की बात होती है तो लर्निंग ऐसे करना है जहां पे आपको उसको फ्रीनेस देना है बट विद इन कंस्ट्रेंट. तो वो जो डिस्ट्रीब्यूटेड कंस्ट्रेंट्स में हमने बात किया था इन आवर प्रीवियस यूनिट, तो वहां हमने उसको कॉन्स्टेंट्स बता दिए हैं. अब उन कंस्ट्रेंट्स को यूज करके वो अपने जो लर्निंग हायरार्की है उसको इम्प्लीमेंट करेगा, एल्गोरिदम्स फाइंड आउट करेगा. ओके, एंड देन ही विल गो फॉरवर्ड. फाइन. सो दिस इज नाउ it may be possible that given some examples two learning algorithms can learn to perfectly classify them, है ना. तो जैसे कि यहाँ के केस में, इसी केस में क्या हो रहा है कि हमारे पास 3 different learning algorithms आ रहे हैं. ठीक है. So F1, F2, F3, all 3 algorithms are classifying correctly or clustering uh, your minus values correctly. So what you are getting is you are getting perfect classification from 3 different learning algorithms. Your F1, F2, F3 being the functions, है ना. So since 3 different algorithms are there, so you will get the different functions also as you are getting over here F1, F2, F3. So this concept is known as induction bias. This concept is known as induction bias. Okay, what is this induction bias? So when you have a goal and that goal can be achieved by implementing 3 different algorithms or 2 different algorithms or multiple algorithms, and even though the multiple algorithms are implemented, you are getting different functions also. So the this particular scenario is known as induction bias of a learning algorithm. ठीक है. सो इंडक्शन बायस क्यों कहा जाता है? यहाँ पे बायसिंग हो रही है. सो ऑब्जर्वेशंस अगर हम प्रॉपरली हमने ऑब्जर्व किया है वैल्यूज को, सो वी शुड गो टू अ पर्टिकुलर व्हाट इज हैपनिंग ओवर हियर कि भाई एक ऑब्जर्वेशन O1 है, एक ऑब्जर्वेशन O2 है, एक ऑब्जर्वेशन O3 है. ठीक है, यहाँ इंडक्शन यूज हो रहा है. करेक्ट. हम ऑब्जर्वेशन से कहाँ पे जाएंगे? थियरी की तरफ जाएंगे. सो नॉर्मली योर O1, O2, O3 should go to same theory T. करेक्ट. सो बट यहाँ पे क्या हो रहा है कि O1, O2, O3 they are classifying in three, but there are 3 different algorithms A1, A2, A3. So this cannot be achieved. Fine. So in this case, if O1, O2, O3 they are using algorithms A1, A2 and A3 and they are still reaching some T. Fine, they are trying to reach the goal and they have reached T. But what you will get over here are 3 different functions F1, F2, F3. Okay. So herein there was some biasing in the observations. So observations में biasing हुआ, that's why the induction bias came for this particular learning algorithm, है ना. And when we say that induction bias has occurred, fine, let me write it over here. Okay, and when we say that an induction bias has occurred, so because of this induction bias, some learning algorithms appear to perform better than others in certain domains. Okay, you can see कि भाई हमने क्या बात किया था कि F1, F2, F3 आपके पास 3 functions आ चुके हैं. अब which is better optimized, which is the optimized function that you will be doing. But अगर आपको पास F1, F2, F3 नहीं होते, so कोई optimization principle की जरूरत ही नहीं पड़ती, है ना. तो यहाँ पे इम्पोर्टेंस क्या है, क्यों इतना डिस्कशन हो रहा है? वी मस्ट अंडरस्टैंड व्हाई दिस अ लॉट ऑफ डिस्कशन आई एम डूइंग विद रेफरेंस टू द 3 different फंक्शंस, है ना. भाई हम लर्निंग की बात कर रहे हैं. ठीक है. अगर हमने लर्निंग किया है और हमारे पास इंडक्शन बायसिंग हो रही है, सो इट मींस दैट कि हमारे पास 3 different एल्गोरिथम्स आ रहे हैं एंड 3 different एल्गोरिथम्स में कौन सा बेटर है हमें फाइंड करना पड़ेगा. ठीक है. ये इंपॉर्टेंट है, ये वेरी क्रूशियल पॉइंट है. व्हाई? बिकॉज at least you the agent gets to know that if there are gets to know that given a problem there are 3 ways with which I can solve this particular problem. So if I get some So first, what I will do is I will solve this particular problem. So I get to know that three different ways are there to solve this particular problem. Now I will try to find the optimized way. So I have the optimized way also. I have three different problems also, है ना? An optimized way among those three problems. Now, even though at some point of time that agent uses that optimized principle and finds that there is some problem occurring, or there is some error occurring in implementing that particular problem. So since the agent must work in real time scenario, at least they have two more solution strategies to reach the goal. Correct? So दिस इज व्हाट लर्निंग इज। लर्निंग का मतलब ये नहीं होता है कि मैंने आपको कह दिया कि क्या कहते हैं, यू हैव टू राइट अ पर्टिकुलर, यू हैव टू गिव अ राइट अप ऑन अ पर्टिकुलर टॉपिक। सो इफ आई से कि भाई यू हैव टू राइट हाउ आई राइट, दैट इज नॉट द करेक्ट वे ऑफ giving you the goal. Okay, if I can say that you have to write in your own words as per your understanding, as per your learning, but there are certain constraints that we are normally doing ना भाई। हम असाइनमेंट्स देते हैं आपको या क्विजेस देते हैं, तो वहां पे हम कुछ कॉन्स्टेंट्स रखते हैं कि डेडलाइन पे देना है। ओके, एंड जैसे मैंने आपको टर्म पेपर दिया है तो मैंने आपको बताया है कि प्लेगरिज्म नहीं होना चाहिए, या प्लेगराइज्ड कंटेंट जो है वो टर्निटिन पे चेक करके मैं देखूंगा तो मार्क्स डिडक्ट कर दूंगा। करेक्ट? सिमिलरली आई टोल्ड यू सम अदर थिंग्स ऑल्सो कि भाई आपका रेफरेंसेस ऐसे दिखना चाहिए, वैसा होना चाहिए, ये होना चाहिए, ऐसा होना चाहिए। करेक्ट? सो व्हाट आई एम ट्राइंग टू टेल यू इज आई एम ट्राइंग टू गिव यू कॉन्स्टेंट्स। तो पहले तो मैंने आपको क्या बोला कि यू राइट द टर्म पेपर इन योर ओन वर्ड्स एंड विथ योर अंडरस्टैंडिंग, विथ योर वॉट एवर your whatever you have read, okay, in last 2 months. But at the same time, to check the performance also I am doing all these things, है ना? So learning, आपकी learning check करने के लिए मैंने क्या किया, आपको एक problem दिया। Now you are giving me, so since 114 students are there, 114 students, if the same problem is given, 114 students may write their own version of the paper. Now I have to try to find the performance or best out of those 114 versions. So उसके लिए मैं क्या करूंगा, कुछ constraints का यूज करूंगा। ठीक है? So वही चीज एजेंट्स के केस में भी होता है। आपने बता दिया कि ओके, दैट वन एजेंट, वन रोबोट इज देयर that does all the works of LNMIT as a postal man. Okay, now the robot starts from LNMIT. You tell him that tell that particular robot that you have to go to Jamdoli. From Jamdoli, you have to take the road that goes directly to Sisodia Rani Ka Bagh and then enter into the city. Okay, so if there is some problem happening on that particular road, either that robot will be stuck, or else if you have given that the instruction that if you are stuck, return back, then every time it will return back because that road is blocked. Instead of that, you can say that your goal is to reach at this particular place, and you can give that particular robot the GPS mapping. Okay, and with the use of GPS map, the robot can reach. Okay, and it can learn now. Now you are also knowing that robot has learned that there are two different ways from Jamduli, and there are other ways also if we go further, and likewise we can reach, है ना? They can understand कि भाई a robot can understand that okay, I am a four-wheeler robot, so I am only allowed to go via from the cave, okay, that is built just before entering the city. If I'm a two-wheeler robot, I am not allowed from the cave, so it has to take that particular decision, है ना? So this is how the learning happens. Fine. Now, uh, the, this is the concept what I told you about the induction bias. Now, and the importance of induction bias. Okay. Now there is a concept called no free lunch theorem. Okay. No free lunch theorem. As the name suggests, भाई कोई भी लंच फ्री में नहीं मिलेगा, इसके लिए आपको कुछ तो पे करना पड़ेगा। ओके, सो व्हाट happens over here, now I am telling you that there are a lot of problems, there are a lot of learning algorithms that you can devise for a particular problem. Now what no free lunch algorithm says that if you have a problem, okay, and if you have different algorithms, okay, and if the algorithm outperforms all other, okay, then it cannot be categorized as no free lunch theorem. Okay, so what it says that we um, if you have all possible learning problems and you find the average over all possible learning problems, so there are no learning algorithms, no learning algorithm that outperforms all others. Now, what is the significance of this particular statement? So, the, with this, we get to know that we have to integrate the knowledge into learning algorithm. Okay. Now, we cannot say that a specific problem is given, so there is some algorithm that will outperform all. If the problems are there, sorry, if the solutions are there of a particular problem and there are multiple solutions, so solutions are there, it means कि भाई, with the use of any of the solutions you are reaching the goal. But you cannot say that a particular solution outperforms all the others. You say that given a particular situation or given a situation, a solution outperforms other. But generally or in a generic form, you cannot say that a particular learning algorithm outperforms all other learning algorithms. Okay. However, I am telling you, given a situation, you can say that. Given a constraint, you can say that. But generic form, you cannot say that. Fine. So that's what the concept of no free lunch algorithm. है ना? So let's write this particular algorithm in a more proper way. Okay. So I am denoting this as NFLT. Okay. So what is NFLT? NFLT says that any two optimization algorithm, any two optimization algorithms are equivalent when their performance is averaged across all possible problems. So this is what your no free lunch theorem is. Fine. Now let's talk about moving target function. Okay, what is your moving target function thing? Okay, so what is your moving target function? So whenever a learning agent is placed in a multi-agent scenario, okay, so therein some fundamental assumptions of machine learning are violated. Okay, how? So the agent may no longer learn to extrapolate from the examples, है ना? So it tries to keep changing its solution, or it tries to always change the learning, है ना? So why this happens? Because the target always keeps changing, है ना? In here what happens? कि the target changes means the goal changes, है ना? And what is the reason behind it? It happens because of your dynamics of real time situations, है ना? Because of real time environment, the target always changes, and target changes because of that. No long means learning algorithm try to extrapolate from the examples. So therein what happens, this function that is achieved is with respect to the moving target. and this problem is known as moving target function problem. Fine. So generally to speak, the target concept does not change randomly, है ना? So it changes based on the dynamics of the system and whatever the रियल टाइम सिचुएशन इज, है ना? रैंडमली कुछ नहीं होता है, मैंने पहले भी आपको बताया, रैंडमनेस इज अ टेंजाइबल कंसेप्ट, इट इज नॉट इन रियल लाइफ, नथिंग इज रैंडम, ओके? तो प्योर रैंडमनेस कैन नॉट बी अचीव, ओके? तो वो क्या होता है, हमें रैंडम इसलिए लगता है बिकॉज हमें क्या है, अभी अभी अपनी आंखों के सामने सर्टेन मॉस्किटो इज देयर एंड इट चेंज इट्स पोजीशन, एंड हमारा जो आईज है, उसके जो पिपल्स हैं, इट कैन नॉट चेंज द पोजीशन दैट रैंडम दैट फ्रीक्वेंटली। तो उससे क्या होता है कि हम हमें ना रैंडमनेस का एहसास होता है, सो दैट्स व्हाई वी कॉल इट रैंडम, ओके? So what these agents are doing, the target concept does not change randomness because it changes its target, the target gets changed because of your real time situation, है ना? So it is a very complex scenario na, and this is basically, this scenario is very complex in nature, and when this complexity is implemented for machine learning, sorry, if you want to implement machine learning algorithm to achieve this complexity, it is a very tedious task, है ना? And this what we are trying to achieve in current scenario, हम यही चाह रहे हैं ना, ये complexity को मैप करना चाह रहे हैं, इसलिए तो इतना पढ़ रहे हैं, है ना? तो अभी क्या होता है कि हमने ये पहले भी बहुत डिस्कस किया है कि जो लर्निंग एजेंट्स है, दे आर मोस्टली सेल्फिश यूटिलिटी मैक्सिमाइजर्स, है ना? दे आर रैशनल बस, बट दे आर रैशनल इन टर्म्स ऑफ द फैक्ट दैट दे वांट टू मैक्सिमाइज द यूटिलिटीज ऑफ देमसेल्व्स, है ना? सो दे हैव टू फेस ईच अदर इन डिफरेंट एनकाउंटर्स। अभी क्या है कि भाई, जब हमने बॉब एलिस का एग्जांपल देखा था, है ना, वेयर साइमल्टेनियसली दे आर ट्राइंग टू टेक सर्टेन एक्शंस, है ना? तो what they are getting certain utility payoffs also ना। हमने वो एक प्रॉब्लम देखा था जिसमें हमारे पास some payoffs we were getting, है ना? payoffs we were getting some payoffs for Alice and Bob. So here they are playing the game simultaneously, है ना, and they are trying to maximize their utility, है ना? अब मैं आपके सामने एक प्रॉब्लम रखता हूँ, भाई अगर मान लो कि तुम्हारे पास एक मार्केट एरिया है, वहां पे आपको जो है मार्केट प्लेस में योर एजेंट हैज टू गो फॉर सम ऑक्शन, है ना? सो व्हाट विल हैपन whenever the outcome of that particular auction happens, so that auction happens simultaneously, किसी को बताया तो जाता नहीं है कि इसने इतना बिड किया है तो तुम भी इतना बिड करो, everybody has to bid, give his or give their bid based on their own understanding, है ना? And when the bid opens, so the agents will get a utility gain or loss based on um, gets the who wins that particular auction, है ना? तो similarly अगर आपके पास एक robot है ना, and those two robots, they are going against each other, they are moving against each other in front of themselves, so whether they are colliding with each other or they are changing their course so as not to collide, based on that you are giving some utility payoffs to that particular robot, है ना? जैसे कि हमने कौन से प्रॉब्लम में देखा था, गेम ऑफ चिकन्स में देखा था, है ना? टू adults, they were driving against each other, है ना? तो what is happening over here, है ना? agents, they are trying to learn for themselves, है ना? अभी क्या हो रहा है कि um, दो रोबोट है, those two robots और those two agents are trying to move towards each other, भाई उनको टकराना है, टकराने से टकराने से पहले हो सकता है एक एजेंट सोचे कि आई विल नॉट क्रैश विद दैट पर्टिकुलर रोबोट and try to see my payoff utility, and based on that I will decide in the next phase of this particular game. Similarly auction में भी यही होता है, मार्केट में जो आप ऑक्शंस होते हैं फॉर अ पर्टिकुलर कोटेशन एंड ऑल जो होता है फॉर अ पर्टिकुलर प्रोडक्ट, तो वहां पे भी यही होता है कि भाई ऑल ऑफ देम आर प्लेइंग देयर गेम, एंड देन व्हेन वंस they are experienced or based on their experience in the first game, whether they won or lose, on the basis of that they will go in next round of auction whenever that particular auction is there. So what we are trying to say is कि the cooperative learning we must understand, है ना? So what is this cooperative learning? Let's talk about that. This is very important, huh? Cooperative learning. We will see it once again when we discuss cooperation, collaboration, and coordination. Okay, after this particular topic is over. So, what happens in cooperative learning? So, um, let us, we have a scenario. Let us talk about a scenario. What is that scenario? So, a scenario says that you have two robots. Okay, you have two robots. What they have? They have wireless communication capability. Okay, what is their task? The task is to map the environment, map the unknown environment, है ना? Their task is to map the unknown environment. Fine. Now, maybe possible that two robots are having the same kind of same. They are homogeneous in nature. Okay. So understand how you can go for learning in multi-agent systems. Before that, we must understand the scenario. So what could be the case? By let us suppose there are two kinds of rocks in that particular field. One is of red color and one is of black color. So one robot or robot one, let us suppose, it says that red is heavy, so it cannot be lifted. It is lighter, so I can lift this black rock. Okay, then when what is this? This is the local view of robot R1. Fine. Now, if the same thing has to be sensed by R2, then what is the need of means what is the need of making a multi-agent system? The agents are basically working alone or stand alone or independently, है ना? So when we talk about multi-agent systems, then interaction must be there, है ना? And interaction का कुछ result होना चाहिए. So here the interaction in terms of cooperation. What R1 can do? R1 can share this result with R2. Fine. R1 is sharing this result with R2. So what R2 is understanding that, okay, red is heavy. I should not try to lift even red because it is understood or it is shared to me by R1 that red is heavy. Because उसको sense करने में, उसको monitor करने में, check करने में भी तो R1 R2 की कुछ energy consume होगी. Okay, हो सकता है कि उसको check करने के चक्कर में जो उसका mechanism है that can get destroyed. Okay, so that mechanical system is there that can get destroyed, है ना? So what is happening over here? So robots are trying to communicate the information to one another, है ना? So why? Because they don't want to relearn the same thing. Relearn must be avoided. So they don't want to relearn the same thing, है ना? So there now here R2 will have, when receiving, they will have this R2 will have in its information that red is heavy and black is lighter. So R2 will go directly and do the operation of lifting the black rock. Fine. So this is always correct. This situation is always correct when you assume that R1 and R2 are homogeneous. What do you mean by homogeneous? Means they both have same kind of characteristics, say they both have same kind of mechanism to do the things. They both have, both are cooperating with each other in order to build the map, है ना? Now this is very simple problem. Now the challenge comes when robots are trying to tell the things they already know, but these robots are heterogeneous in nature. So what is the first challenge in cooperative learning is heterogeneity. हेट्रोजिनिटी का मतलब क्या होता है कि भाई एक रोबोट एक तरीके से डेटा स्ट्रक्चर सेव करता है, सेकंड रोबोट दूसरे तरीके से डेटा स्ट्रक्चर अपना क्रिएट करता है. हो सकता है कि एक रोबोट का काम दूसरा है, दूसरे का काम दूसरा है. दे आर नॉट आइडेंटिकल इन सम एस्पेक्ट, है ना? तो देर क्या हो सकता है कि भाई एक रोबोट ने पता कर ही लिया है कि ब्लैक रॉक्स कैन नॉट, सॉरी, रेड रॉक्स कैन नॉट बी मूव्ड, है ना, एंड ब्लैक रॉक्स कैन बी मूव्ड, है ना। बट मे बी पॉसिबल दैट R2 के पास क्या है, R1 ने पता कर लिया, R2 से शेयर कर लिया, बट R2 के पास क्या है, लार्जर आर्म है एज कंपेयर टू R1 फॉर लिफ्टिंग द रॉक, सो डेफिनेटली it will lift the red rock even though it is heavy. However, we must understand that even though the heterogeneity is there, if R1's data is shared to R2, then R2 directly goes and lifts that particular rock, and it will help in making an informed decision making on their aspect. है ना? So this is one of the challenge. Second challenge is the modeling capability. What is this modeling capability? So there are two different robotic agents, है ना, they are modeling their problems in two different ways, है ना. One wants to just see कि which is lighter and which is heavier, and then inform its mechanical system to lift that particular rock. Second agent is trying to learn, or if the data is already shared, then try to see that particular information, and then asks its its mechanical system to adjust itself in such a way as to lift the heavier rock also. So the modeling capability also differs. So if you are trying to learn in that particular environment, so what will happen in this case, all the lighter, when, so what is happening with these two challenges also, if you try to map this particular challenge, so cooperation is happening how, so they are learning, but how, so R1 may be possible always, what it does, it lifts black rock, because it is lighter, and R1 knows that it cannot lift uh, heavier rocks. So what R2 does, R2 knows that R1 has shared this information with me, and we both are not the same. So it may assume that R1 is lifting black rock, so I will lift red rock. So what is happening over here? So R2 knows the information of R1 or vice versa. And based on that information, R1 is lifting the black rock and getting some payoff matrix, payoff utility. Similarly, R2 is lifting red rock and it is getting some utility payoffs. है ना? So they are getting some values, they are getting some utilities, they are understanding each other's scenarios, and they are doing their own work, but finally the mapping, that is the goal of this particular problem, can be successfully achieved. Why? Because cooperation R1 and R2 के बीच में was possible. ठीक है? So we will see in coming lectures, we will discuss about repeated games, and we will see how this cooperation can be explored more. Okay, so till then, thank you very much. Have a nice day. We will discuss all these things in the coming lecture. Okay, and I expect that in the next lecture you come by going through, by viewing this particular video and going through all the concepts that I have discussed in this lecture, because I will be starting from the next concepts in my next lecture. Okay, after your midterm examinations, definitely. Okay, thank you very much. Have a nice day.